today we are going to talk about the experiment number 5, which is application of potentiodynamic polarization for comparison of actively corroding alloy and passivating alloy. It is also called as PDP, that is potentiodynamic polarization. So this is a electrochemical technique used to study corrosion behavior of different materials, in which you apply a controlled voltage switch to a metal sample and you measure the current. This is the electrochemical setup for the experiment. For this experiment, you will be provided two different materials. One is mild steel and stainless steel. So your working electrode is mild steel or stainless steel. Reference electrode is saturated caliber electrode, and counter is platinum based electrode. And for this experiment, 0.5 molar H2SO4 will be your electrolyte. So after performing this experiment, you will get the curve. So this curve is called as polarization curve. The polarization curve helps to find out whether the given whether the provided metal is actively corroding, or it is passivating, or it undergoes localized corrosion. So we'll now see how to differentiate between the mild steel and stainless steel based on the polarization curve. So this is the plot for mild steel, in which y-axis is potential and x-axis is current density in ampere per centimeter square. First of all, to get this curve, you have to first find out the OCP, and then you apply 250 millivolt potential toward the cathodic side and 250 millivolt toward the anodic side. So you can see that the plot is divided into two parts. One is anodic region and one is cathodic region. So as the solution is acidic in nature, so on cathodic side a reduction happens. So here the hydrogen will get reduced to the hydrogen. H plus will get reduced to the hydrogen, and mild will get on the anodic region oxidation happens, that is iron get oxidized to iron 2 plus. So here you can see that even with increasing potential, the current is continuously increasing, because the difference between because the mild steel does not form a passive oxide layer. So even though you go toward the higher potential, you will see the same nature of this curve. So this is for the mild steel. Now we'll see how the stainless steel is different from the mild steel. So this is the polarization curve for the stainless steel. You can see that the cathodic region is same, because in both the mild steel and stainless steel, the cathodic reaction will be the same, that is the hydrogen evolution. But in the anodic side, you can see that initially when the current potential is continuously increasing, the current is also increasing to this point. But after this point, the current is continuously the current is decreasing, because at this point the passive layer is formed. So this passive layer doesn't allow for the corrosion. So because of which the current is decreasing, and at one point even though potential is increasing, the current is constant. But even at higher potential, the passive layer layer is not stable, and it breaks down. So when the passive layer breaks down, you can see the current is sudden increase in the current. So you can see the difference between mild steel and stainless steel. In stainless steel, there is no passive region, whereas in stainless steel you can see a passive region because of the stable oxide layer formation. So now we will see what are the objective of this experiment. First one is to find out the corrosion potential and corrosion current. For that, you need to take the slopes 50 millivolt below the OCP and 50 millivolt above the OCP, and then extrapolate this slope where they intersect, and then at this intersect, the x-axis is x coordinate is corrosion current, and the y coordinate is your corrosion potential. Then is pitting potential. So the point where you see there is sudden increase in the current is called pitting potential. So next is passive potential. So where the current starts decreasing, that potential is passive potential. Then next is the passive current density. So you can see that at the point where the current is constant, that point is called as a passive current density. Then next is the critical current density. The current at the current that you get at pitting potential, passive potential is called as the critical current density, and then the pitting potential, where you see the potential, where you see the sudden increase in the current, is called as pitting potential. So these are the parameters that you have to find out from this law.